Statistics of Malaysia dengue cases from 2010 to 2017. Presented as part of submission for MANB 1123 Business Statistic for Data Science, Master of Science Business Intelligence and Analytics, Universiti Teknologi Malaysia, by Syazwani, Marlina, Melati, Farina, and Tanvir. Chapter 1, Introduction. Dengue is one of the most important arthropod-borne viral diseases in terms of human morbidity and mortality in Malaysia. Dengue viruses are transmitted to humans through the bites of a striped Aedes aegypti mosquito that has previously bitten an infected person. The WHO estimates that 390 million dengue virus infections occur every year, 70% of which are in Asia. What's most troubling is that the number of cases continue to rise annually, with 2019 being the year with the largest number of dengue cases to ever be reported globally. Tan Sri Dato Seri Dr. Noor Hisham bin Abdullah has described the rising trend as alarming and should serve as a reminder that the country should not neglect the fight against dengue, even as it has its hands full battling the COVID-19 pandemic. At the 10th ASEAN Dengue Day, he added that it only takes at least 10 minutes to clean your surroundings and destroying breeding grounds of Aedes mosquitoes to protect yourself and your loved ones. In Malaysia, onset of dengue infection was dated back in year 1901 following transmission from Singapore to Penang. First epidemic outbreak was then alarmed in 1973, recording a total of 969 cases and 54 deaths. The outbreak of dengue happens due to the population growth, indiscriminate disposal, lack of efficient solid waste management, and the efficient movement of dengue viruses through modern transportation. In this analysis, we study the number of cases of dengue outbreak in Malaysia population from the year 2010 to 2017. Objective of this study is to analyze the distribution of dengue cases and mortality according to region and age, to analyze the relationship of population density to the number of cases, to analyze the dengue death cases, and to identify the time series pattern and forecast the number of dengue cases in Malaysia. We have divided the analysis into descriptive analysis and inferential statistics, where we study the number of dengue cases according to geographical, demographic age, population density, hypothesis testing, and forecasting model. Chapter 2, Dataset. The dataset was extracted from the open data source of Malaysia's government at data.gov.my website provided by the Disease Infection Control Department, Ministry of Health, Malaysia. The dengue dataset consists of the number of dengue cases by states and range of age, number of annual dengue deaths by state, and number of dengue cases weekly by state. All data ranging from the year of 2010 to 2017. Meanwhile, population data by state are extracted from the Department of Statistics, Malaysia. The data is pre-processed to segregate number of cases in states according to regions, the Central, South, North, East Coast, and East Malaysia. The weekly cases was converted to monthly cases to analyze the monthly dengue cases time series patterns throughout the year 2010 to 2017. Chapter 3, Descriptive Statistics. This chapter uses a number of charts and also a numerical view to present the data that we have collected on dengue cases in Malaysia from year 2010 to 2017. It is divided into several sections in which we are going to present the answers to the following questions. How bad is dengue cases comparing between regions? Which Malaysia region has the highest rate of dengue? What does the numerical presentation of dengue mortality data tell us? From 2010 to 2017, Central Region has relatively more cases within age range of 20 to 24 years, 14.5%, than the rest of the region. At all other levels of age range, Central Region has relatively highest cases than the rest of the region at 314,000 cases. From 2010 to 2017, Central Region was the highest number of overall dengue cases and East Malaysia Region being the lowest. In Central Region and Southern Region, the highest affected population in age range 20 to 24, while in East Coast region, Northern region, and East Malaysia highest affected population range between 15 to 19 years old. All cases experience decreasing trend as number age class increases respectively after maximum number of case point. From 2010 to 2017, the median point of Central Region data lies outside of the rest of the regions, meaning that Central Region obviously can be treated as exclusive group, while the rest of the region can be treated as a combined group. This would mean that a special management alone needs to handle the cases if the audience intention needs to trim down extreme cases. Being that there are high cases in Central Region, does the Central Region has higher mortality rate mean than the rest of the regions? Part 1. Check normality distribution. Check sample size. N equals 5. Test normality. To summarize Part 1a. Mean equals 95.40, which is near to value of median equals 98.0. Skewness equals 0.115, between -0.5 and 0.5, for fairly symmetrical. Kurtosis equals 1.740, which is near to 0 for normal distributed. Hypothesis statement for normality test. H null, data is normally distributed. H alternative, data is not normally distributed. To summarize Part 1. Given n equals 5. N less than 50 samples, therefore take Shapiro-Wilk result. P-value is 0.674 more than alpha equals 0.05, thus H null is accepted. Noted that we have checked the normality that shows that the variable current follows normal distribution. Therefore, for one sample test, we will use t-test. Part 2, the t-test. Given Central Region standard deviation, S equals 45.933 death, equals 95.40 death. Hypothesis statement. H null, 95.40 more or equal to, average other region death. H alternative, 95.40 less than, average other region death. Evaluate the risks of making type I and II errors, and choose the level of significance of alpha equals 0.05. From the result, Central Region standard deviation, S equals 45.933 death, equals 95.4 death. Other region standard deviation, S equals 76.938 death, equals 185.0 death. To summarize, we accept the alternative hypothesis that the average Central Region death is less than average other region death. Chapter 4, Inferential Statistics. Correlation Analysis. To see the relationship of dengue cases according to high density of residential area, Sabah, and low density of residential area, Labuan. Correlation is conducted to measure the strength of relationship between density of population in residential area according to the state and total number of dengue cases. Total population for 16 states for the year 2017 are 57,935,100 in Malaysia. Data was extracted from Department of Statistical Malaysia, DOSM. The highest population is Selangor, which is 32,022,500. The lowest population is Labuan, which is 97,500. In this study we will compare the number of dengue cases according to high density area vs low density area in East Malaysia region. Data was filtered according to state and number of population using pivot table in Excel. Since data is not normally distributed, the non-parametric statistical test was conducted using independent variables. Significant value shows p-value equals 0.00 less than 0.05, hence the null hypothesis is rejected. H null, high-density residential case equals low-density residential case. H alternative, high-density residential case more than low-density residential case. The graph is showing Sabah has highest dengue cases compared to Labuan because Sabah has high density of residential population than Labuan. Thus, H alternative is accepted. The correlation analysis was conducted using Spearman correlation. Data is non-parametric, not normally distributed. The relationship pattern is non-monatomic. Dots become more dispersed as number of population low and dengue cases also lower. It can be summarized that, the lower the population number, the lower the dengue cases. Dengue death case analysis. In this section we are going to visualize death cases of Malaysia from 2010 to 2017 by state in different representation. We also conduct a normality and hypothesis test using the death case data set. Using Power BI, we have visualized the death case of Malaysia from 2010 to 2017 by state. We have found that Selangor has the highest mortality rate when WP Labuan has the lowest one. We have also found that the most death case occur in the year 2015. On the other hand, the year 2012 contribute the least death case. Total 1,262 people had died from dengue disease from 2010 to 2017. The normality test shows that mean value is slightly similar to the median value. The skewness is also between 0.5 to 0.5. That means it's fairly symmetrical. The Kurtosis value is near to 0 for normally distributed. Sample size n is less than 50, then we will use Shapiro. P is greater than alpha value, thus the H null is rejected. It indicates it's not normally distributed. In the hypothesis test, significance value is less than alpha value. So, null hypothesis is rejected. That means yearly average death case in the sample is not less than or equal to the 80. Time series forecast. In time series forecast, the time series pattern was identified to forecast the dengue case in Malaysia. Forecasting results of dengue cases could be useful in preparedness program to facilitate the planning of public health interventions. The monthly dengue cases is plotted to visualize the pattern of the outbreak. The time series plot of 104 months of dengue cases from the year 2010 to 2017 have exhibited an irregular and random movement above and below a constant mean. There is no trend and no seasonal pattern. Hence, a possible forecasting tool is an exponential smoothing model to smooth out the random or irregular components in the time series. The exponential smoothing formula is given by the equation of new forecast equals to last period's forecast plus alpha times last period's actual demand minus last period's forecast, with alpha is a weight, or smoothing constant, that has a value between 0 and 1. The value of appropriate smoothing constant, alpha, will be determined to evaluate forecast accuracy that better fit the forecast model. In this case, we tested the difference of alpha equals 0.2 and alpha equals 0.4 with respective damping factor of 0.8 and 0.6. In order to evaluate the best smoothing constant of alpha value, mean absolute deviation, MAD, mean square error, MSE, root mean square error, RMSE, and mean absolute percentage error, MAPE, is calculated and compared. Looking at the bold results in blue, the value of MAD and RMSE for alpha equals 0.4 is lower than alpha equals 0.2, which indicates that alpha equals 0.4 have better forecast accuracy. Meanwhile, the MAPE value of 16.86% indicates alpha equals 0.4 have good forecasting instead of acceptable MAPE value for alpha equals 0.2 with 24.61%. By comparing the exponential smoothing forecasted value with the actual number of cases in the time series plot, the smoothing constant, alpha equals 0.4 provides better fit to the actual number of dengue cases for 104 months compared to alpha equals 0.2 with concentrated values to the actual line. Hence alpha equals 0.4 can be used to forecast the subsequent monthly dengue cases at 105th month. At the month of 105 located in 2018, it can be forecasted the monthly dengue cases are 4,078 with exponential smoothing of alpha equals 0.4. Conclusions. At the end of this study, we can see the pattern of dengue cases in Malaysia from the year 2010 till 2017. The central region, which consists of Kuala Lumpur, Putrajaya, and Wilayah Persekutuan, had the highest dengue case with 314,665 cases, followed by southern, northern, east coast, and East Malaysia. We have found the correlation that the lower the population number, the lower number of dengue cases. At the central region, the highest group of age affected by dengue was between 20 to 24 years old. This was because these groups often stayed outside of the house and prone to getting bitten by Aedes mosquito. The least age affected by dengue was 70 years old and above. The highest death case was in Selangor with 444 cases, and the lowest case in Wilayah Persekutuan Labuan with 0 case. Last but not least, we also had forecast the dengue cases for the month 105 at 4,078 cases by using exponential smoothing factor of alpha equals 0.4. With that, thank you for watching.